Before the mushroom cloud, there was an X-ray machine. The atomic bomb didn't start with war. It started with curiosity.
The temperature at the center of the bomb reached 120 million degrees. 70,000 people are killed. The war ended, but not the dying. Radiation sickness would kill thousands more.
In 1945, the world witnessed the power of science and its darkest potential. But how do we get there? What if I told you that the road to the most powerful weapon in history began not on a battlefield, but in a lab, and with nothing more than a glowing screen? In 1895, Wilhelm Roentgen discovered something strange while experimenting with cathode rays. He called them X-rays, invisible energy that could pass through skin and show bones. It was the first sign that there was more to atoms than anyone thought. A year later, Henri Becquerel left some uranium next to photographic plates by accident and found that they had been exposed even in the dark. He had discovered natural radioactivity. Atoms weren't just solid balls. They were alive with energy. Marie and Pierre Curie picked up where Becquerel left off. They discovered two new radioactive elements, polonium and radium. They gave the world a new word, radioactivity, and showed that some elements release energy just by existing. For the first time, scientists weren't just discovering atoms, they were watching them fall apart. In 1911, Ernest Rutherford fired tiny particles at a sheet of gold foil. Most passed through, but a few bounced back. That didn't make sense unless the atom had a solid center. He discovered the nucleus, a dense, powerful core hidden inside every atom. A few years earlier, Albert Einstein had written something simple and terrifying. It means mass can be turned into energy. A tiny amount of matter holds an enormous amount of power. At the time, it was just an idea, but one day, that equation would be used to level cities. In 1938, two German scientists, Otto Hahn and Fritz Strassmann, were trying to make new elements. But what they saw shocked them. They had split the uranium atom. It wasn't just breaking, it was releasing a burst of energy. This was nuclear fission. Einstein's equation wasn't theory anymore, it was a trigger. This is where things started to change. The science wasn't just interesting anymore, it was dangerous. In 1939, a Hungarian physicist named Leo Szilard saw the danger in fission and panicked. He teamed up with Einstein to warn President Roosevelt. A bomb was now possible, and Hitler might get there first. This letter lit the fuse. The U.S. took the warning seriously. By 1942, the U.S. launched the Manhattan Project, a secret program to build the bomb. Thousands of people worked across the country. It wasn't just science anymore. It was war and a race against time. On July 16, 1945, in New Mexico, the first atomic bomb was tested. They called it Gadget. At 5:29 a.m., the desert lit up. The sand turned to glass. The shock wave traveled for miles. Oppenheimer quoted the Bhagavad Gita, "Now I am become death, the destroyer of worlds." The scientists didn't just build something. They unleashed something. On August 6, 1945, a single bomb was dropped on Hiroshima. In seconds, tens of thousands of lives were gone. 3 days later, Nagasaki followed. The war ended, but the world had entered a new age, the nuclear age. The bomb changed everything. It ended a war, but began a global arms race. For the first time in history, humanity had the power to destroy itself. Science gave us the power to unlock the atom, but it also gave us a choice how we use that power. This story isn't just about physics. It's about people and consequences. And maybe that's the real lesson. Knowledge is never neutral. It's what we do with it that matters.